Okay, all right. So this is my third class on organic chemistry. And like I told you, we are moving on with the JUPEP syllabus. So on the JUPEP syllabus, our next topic is written on the board already, but I want to show it to you. So this is our next topic. We started with tetravalency and hybridization of carbon. So the next thing, under this T hybridization, we need to look at the type of bond before we now look at the bonding system in alkanes and alkenes before we now look at homologous series. But today we are looking at sigma and pi bond. So let's start. What is sigma bond and what is pi bond? The sigma bond, to understand this and to understand pi bond, please, I want you to pay attention because you will be the one to access whether you really understand this thing or not. So this sigma bond and pi bond, to understand it, we need to first and foremost have a knowledge of what is called orbital. In our chemistry, we have what is called s orbital. This is s orbital. We also have what is called p orbital, and this is how to write p orbital. This is how to write p orbital. So we have s orbital and we have p orbital. Okay, so s orbital and this is a p orbital. Before we can define what sigma bond is, first, make sure you know the meaning of this. It is an orbital. We are going to talk about it in an inorganic chemistry or physical chemistry rather. Then here, this is also p orbital. Now, what is sigma bond? Okay, sigma bond can occur in three ways. Sigma bond can occur in three ways. Number one, when you have s orbital and another s orbital, you can form a sigma bond. You can equally form a sigma bond when you have s orbital plus p orbital plus p orbital, s orbital plus p orbital, s orbital plus p orbital. We can equally form sigma bond using p orbital and another p orbital. This is p orbital plus another p orbital. This is another p orbital. All right, now I wanted to define sigma bond at the onset of this class, but I have not done so. I'm saying that before we can define it, you need to know what an s orbital is. An s orbital is spherical in shape. So this is s orbital. This is also s orbital. S, 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 P, P, P. Now, when you look at the two s orbital, they are placed end to end. They are placed end to end. When you look at this s and p orbital, they are equally placed end to end. When you look at the p orbitals as well, they are equally placed end to end. Now, it simply means in the definition of sigma bond, there are major things that we must see there. Number one is that what type of orbitals do we have? Okay, we can have s and s orbital placed side by side. Sorry. Placed end by end. We can equally have s and p orbital placed end by end. We can equally have p and p orbitals placed end by end. So if I want to define a sigma bond now, the next thing I have to do is that sigma bond sigma bond is the bond formed when s and s orbitals or s and p orbitals or p and p orbitals are placed end by end or placed linearly linearly. So in this definition, you don't need to memorize anything. It's very easy. You don't need to memorize anything. What you must have in mind, number one, what type of orbitals must you have in order to find what is called sigma bond? That is number 1 point. Then number 2 point is, how do they place? Are they side by side or are they end by end? Once you know how they are placed, you must be able to remember anytime. All right. Now, having defined sigma bond, when we have this thing done, what is going to be the result? Okay, there will be an overlapping. So when there is an overlapping, this is what we are going to have. We have this. This is an overlapping of two s orbitals. If this thing happens, there is also another overlapping here, and it is going to be like this. That is another overlapping. If it is like this, it is going to be like this. This is another overlapping. At the end of this class, I will still make sure that I redefine what sigma bond is. Don't worry. Now, when this overlaps, what then happen? When this thing overlap, what then happen? For this one, the result of what we have is this. This is the result of what we have. That is the result of what we have. When this one happens, this is what we have. This one becomes very big, and this one is small. This is what we have. The result of this one will be like this. The two here will be very big. Those two that overlap will be very big. And we have this, and we have this. So this is what we are going to have. So this is a sigma bond, and it is represented by this symbol. It is a sigma bond. This is also a sigma bond, and this is also a sigma bond. So if I ask you again, what is sigma bond? Number one, we need what type of orbitals do we have in order to form a sigma bond? Okay, we need S and S, S and P, and we also need P and P. Whether S and S, S and P, or P and P, we have sigma bond. But it also depends on how they are arranged. If they are arranged end by end, linearly, either linearly or end by end, then we have what is called sigma bond. Now, let me define sigma bond again for you. A sigma bond is formed, or is a bond formed, between two orbitals, whether S and S, or S and P, or P and P when they overlap, by placing them linearly or end to end. By placing them linearly or end to end. Now, that is all about sigma bond. Then the next thing now is that we look at what is called pi bonds. Pi bond is only formed between only one orbitals, only one orbital, p and p orbital. So that means if you want to talk about pi bond now, it is p plus p that will give us pi bond. But remember also that sigma bond can also be formed by p and p orbitals. But what is the major difference? The major difference is that is for sigma bond. But for the pi bond, now when you have pi bond, it is like this. It is like this. This is pi bond. Aha. Now, in sigma bond, they are placed end to end. But in this one, they are placed side by side or side to side, whichever grammar is applicable there. But this is the diagram here. This is the normal diagram here. You can also say they are placed vertically, side by side. They are placed parallel, side by side. So this is what is called pi bond. So this will give me this is pi bond. Right. So this is a pi bond, and we have explained sigma bond before. So this is the end of this class, and this class is from my prof tutor. You can always reach us on 08036167723. And don't forget to like our page on Facebook, and our page is my prof tutor. Thank you.